The next thing that people always ask is, what about the waste? You've got all that used fuel and it's sitting around and it's really dangerous, and it is dangerous. It's dangerous stuff. On the other hand, every electricity supplier ends up making waste. I'm going to be comparing nuclear to coal. I could compare it to gas, but that would be very unfair to both to natural gas because natural gas makes a lot of NOx and stuff in the air, and nuclear makes almost no airborne waste. So I prefer to compare it to coal because coal also makes some solid waste. Otherwise, looking at nuclear compared to natural gas in terms of emission, nuclear wins hands down because it just doesn't emit very much, and it certainly doesn't emit any greenhouse gases, acid rain gases, all the other things that natural gas emits. So let's look at nuclear waste compared to coal waste. Nuclear is low volume. It has a short lifetime, and it's easy to manage compared to ash or liquid. Now, I know this is very counterintuitive stuff, the idea that nuclear waste is low volume. Everybody, no, there's tons of it. Well, not really, not so much as you might think. So nuclear waste is low volume. You see that little Coke can there? I want to talk about two plants I know a fair amount about, and they're both around here. There's the Merrimack Coal Plant in Bow, New Hampshire. It is a 460 megawatt plant, and there is Vermont Yankee. Both of these plants, from a utility point of view, are around 500 megawatts. That is, Merrimack plant is 460 megawatts. Vermont Yankee is 620. They're both sort of the same size, as opposed to one of them being 1,000 or 1,200, or one of them being like one of the biomass plants at 25 megawatts. So they're around the same. Every day, the Merrimack plant gets 40 coal cars of fuel and burns it. The average coal plant in this country burns a coal car worth of fuel, which is about 80 to 100 tons of coal every 20 minutes. It turns out, I calculated for the Merrimack plant with 40 coal cars, that it's a small plant and it burns a coal car full every 35 minutes. This is 100 tons of coal in a car that gets turned over. That is, they lift the whole car up and they turn it over to dump the coal out, because they have to do it faster than they would be able to run it out of a gondola of a hopper at the bottom. Meanwhile, look at Vermont Yankee. Every 18 months, 3 semis deliver all the fuel the Vermont Yankee will need for the next 18 months. So if you were using Vermont Yankee for all your power, then you would be responsible for some little portion of those 3 semis every 18 months. Not a very big portion, because Vermont Yankee makes enough power for about 30,000 homes. So assuming you're in one of the homes, et cetera, et cetera. This is why I'm trying to explain that your waste, the waste you would be responsible for by using electricity, fits into that Coke can. So here's some coal ash. This is ash gone bad. This is a plant down in Tennessee about a year and a half ago that basically the ash pond broke through, the berm broke through, the houses were swept away by a pile of toxic ash, and the river was contaminated and is still in trouble. The houses, of course, are also in trouble. So you think, well, was this rare? No, actually not rare. This is an EPA listing of ash ponds that are high hazard. This is the first page of many, and basically these are all over the United States, mostly in the Midwest and South, but there are 49 high hazard potential units. What makes them high hazard? Their berms aren't in particularly good shape. They're likely to break and push this ash into the environment. Coal ash contains mercury, it contains arsenic, it's pretty nasty stuff, in all honesty. So here's a picture of a coal ash pond, waste storage coal version. This is a ash pond on Mountain Island Lake. The river next to it is the Catawba River. The Catawba River supplies water to 750,000 people. And in Charlottesville, North Carolina, and the area around that. And basically, the people in that area have certain concerns, as you can imagine, that if that berm breaks, they are in deep trouble in terms of their water supply. So that's more waste storage coal version. Here's waste storage nuclear version, a bunch of people standing around dry casks and monitoring them. Those casks can be hit by locomotives, they can be set on fire by jet fuel, nothing will happen to them. The material in them is radioactive, and it is safe to stand around it because it's not that radioactive anymore by the time they put it out in the dry cask. I wouldn't recommend moving a dry cask into your basement, but you can certainly go around it, monitor it, stand around, have a talk with somebody. It's not a particularly high radiation area, and this is how it looks. It's not about to fall into anything, unlike the coal ponds that I just showed you. And here's a picture of dry cask storage showing how that they're built with the steel shell and the reinforced concrete and a man standing next to it and so forth. Just a difference. So if we compare it to fossil waste, it's short-lived because it's radioactive and radioactivity decays. People say, oh, you know, it'll be radioactive for so many years, hundreds of years. Yes, and the mercury in the ash pond is going to be there forever, not hundreds of years, forever. It's not going to decay away. It's just going to get out in the environment and poison things. Similarly, the coal plant is putting out carbon dioxide, and it's going to go in the atmosphere forever, as far as we know. Another thing is that unlike gas streams like the carbon dioxide and the nitrogen oxide, and ash streams, little tiny particles of ash, nuclear waste is relatively easily managed because it's basically a rock. If you put it in amongst other rocks like Yucca Mountain, you don't have to stand around worrying about your Catawba River not being able to supply your water anymore. Now people will say, okay, you wanted to do coal because coal's really bad, but there isn't any coal near us anyway. I don't know if you'd like to look at this. This is a map from SourceWatch. SourceWatch lists coal plants all over the country. The western border of Vermont is New York. There are 48 coal plants in New York. If we begin to close down Vermont Yankee and we begin saying, well, you know, yes, we'll get a lot from the ISO grid, but we'll also be getting from New York, we'll probably be getting more coal than we'd like, coal-fired electricity than we like. There are 12 coal plants in Massachusetts. There are none in Vermont. Air pollution is a very serious health issue. It affects children's entire lives when they get asthma. And luckily, we live in Vermont, which is a great place to live. But half of people in America lives in non-attainment areas. That is, areas where the air pollution is not it leads to non-healthful conditions. That there's just too much pollution in the air for health. Children should stay inside and not play outside certain days, and so forth and so on. And we do not want to have Vermont move into that type of area. We want Vermont to stay what it is like now with clean air. And nuclear is a very good way to ensure that happens. Nuclear and hydro, which is what we mostly have in Vermont right now, is actually just about the cleanest air situation you can get. Most air pollution comes from combustion processes, fossil fuels. I've seen estimates of up to 500,000 deaths per year in the U.S. from air pollution. I've seen so many estimates all over the place. Harvard says 4% of U.S. deaths are from air pollution, which would be less than 50,000 deaths per year. The EPA says merely changes in diesel emissions could lead to about 20,000 fewer deaths from air pollution. And a California study of LA showed 4,000 deaths from smog in LA and 2,000 from traffic accidents. Saying we're going to substitute fossil is not, in my opinion, a winning strategy, even if you decide that there is no problem with climate change. Carbon dioxide is great for everybody. Air pollution, none of this is about carbon dioxide. This is all about particulate, nitrogen oxides, and sulfur oxides, all of which comes from fossil plants.